Let's find the GCF of this. You know that 5, so that means that we cannot simply use the difference of the squares immediately. But if we find the GCF, let's see, for a raised to 5, your factors are 5a's. Then ab raised to 4, you have 1a and then 4b's. Now, how many a's are common? Only one a.
One.
So our GCF here is equal to a. Now, one of the factors is your GCF. Let's find the factor that goes inside. So we divide each by a. A raised to 5 divided by a is a4, right? 5 minus 1 is 4. You'll cancel your a here. So we have minus b raised to 4. We simply copy a and then factor a4 minus b4. 4 is divisible by 2. And we simply get the square root of that by dividing 4 by 2. So square root of a raised to 4, that's a squared. That's a squared plus b squared, and then a squared minus b squared. Are we done here? Check whether we can still factor. A can't be factored. Sum of squares is prime, can't be factored, but this a squared minus b squared can still be factored, right? So you simply copy this and then factor. So factoring after factoring, right? So copy a squared plus b squared, and then this one can be factored. What are your factors for a squared minus b squared? Square of a squared? A, right? Square of b squared, a plus b. The other one is a minus b. So we have 4 factors here. 1, 2, 3, 4. You have 2x raised to 8, y squared minus 32, y raised to 6. 2 is not a perfect square. 32 is not. So that's why to find the factors. First, by getting the GCF, right? So we always try to inspect whether we can apply your difference of squares. If not, then try out GCF. We have 2. Is prime x raised to 8. Factors are what? 8x. Then we have y 32. What's factor 32? You can have 8, 4, right? And then 8 is 4, 2, 4, 2, 2, 4, 2, 2, bring down 2, bring down 2, bring down 2. How many 2's? 5. Wow, that's a lot. So let me write here 2, 2, 2, 2, 2. And then y raised 6, we have 6 y's. And let's circle the common factor. Let's see, we have 1, 2, only 1, 2. Do we have x, y? Yes. Y. So what's your GCF here? 2 y is 2y is 2y squared. All right. So now we have 2y squared. In order to get this, we divide each term by 2y squared, 2y squared. 2 divided by 2 canceled. Y squared canceled. You have x raised to 8. 32 divided by 2, 16. And then y6 divided by y2. Subtract 6 by 2. Y4, y raised to 4, right? So we have 2 y squared times x raised to 8 minus 16 y raised to 8. Notice again that this is a difference of squares. This is a difference of squares, and that means we can vector it. Okay? So we divide 8 and 4 by 2 to get the square root, and 16, we know that's a perfect square. And so let's do copy factor, copy factor. We have 2y squared. When we factor, we have two spaces for the two factors. Right, x raised to 8. What is the square root of x raised to 8? You have x raised to. What will you do with your exponent 8? Divide by 2, right? X divided by 4. 16, what is it? 4. All right, it will be 4. Y raised to 4. Y squared. The other one is raised to 4 minus 4y squared. Now, let's see if we can factor further. Can we still factor? Yes, we can still factor. This one, all right, this is not factorable. Copy, you factor this. So it's factoring. We copy the first two. They are no longer factorable. So we have x raised to 4 plus 4y raised to 2. Sum of squares, like I said a while ago, is not factorable, but the difference is factorable. All right, so let's find the square root of this. Square root of x raised to 4, x squared. Square root of 4, 2. So we have plus 2, y squared, y. Divide 2 by 2 is 1. Right, so x squared plus 2y, and the other one is x squared minus 2y. All right, so this is not factorable, x squared plus 2y, not. How about squared minus 2y? Is it factorable? Although x squared is a perfect square, but 2y is not. So we end there. 2 is not a square, y is not a square. Right, so are we done? Yes, we are done here. We have 4 factors.